Okay, so this chapter called The Mole is covered, most of it is covered today. We have the mole triangle. I want you to pay attention to what this triangle is saying. You will need to memorize this triangle exactly as it is written. The one thing I want to point out to you is the fact that we have these equal signs on all sides. What this is really saying is the molar mass in grams, which is what you did for homework yesterday. That was when you took the periodic table and you added up the number of atoms for each of the different elements that were in the compounds. Okay? So the molar mass is equal to 1 mole. The number of atoms, molecules, or particles, which is 6.02 times 10 to the 23rd, is equal to 1 mole. And 22.4 liters of gas at standard temperature and pressure is also 1 mole. Now, by the way, standard temperature and pressure is 0 degrees Celsius, 1 atmosphere. That would be just standard conditions, and that's where all of these things will be equal to each other at all times. Okay? This triangle is a lifesaver. Yes?
What exactly is a mole?
That's exactly what I'm about to get to. Okay, so I have it up on the board, but I'm going to show you number 1. Now, by the way, this box right here is considered 1 mole. It shows you the 22.4 liters. Like this is 22.4 liters. It shows you that it's equal to 1 mole at standard temperature and pressure. It shows you that it's made up of 6.02 times 10 to the 23rd molecules, or we could call them atoms or particles. But the point is, we don't want to talk about 6.02 times 10 to the 23rd molecules every time we talk about these different gases. That's too big of a number. It is ridiculous to say there's that many particles in this box. These numbers would be huge. I should show this for a minute. It is very accurate. Okay, so if we were measuring it, it would be 6.02 times 10 to the 23rd. But chemists want life to be easy, so we decided to come up with this thing called the mole, and the mole is equal to that many particles. That way, rather than saying we have this huge number of particles, we can just say we have a mole of it. It just makes things simple. Okay? You learn the basics for this chapter. Next chapter is where we really throw you for a loop, so you need to make sure you understand this before you can move on to the next chapter. So let's do the first one together. I have, what is the mass of 7.98 liters of carbon dioxide? You can either choose to write the question down or wait until you take a picture of my paper. But what I need you to do for sure is take out a periodic table, take out a calculator, and we need to make sure you know how to do these calculations by hand. Yes? Yes, I can. Okay. Remember the given, find, conversion factor, and then solution? That's what we're doing. Okay. What is the given for number 1?
7.98 liters.
7.98 liters. What are we trying to find in this question?
Mole.
The mass. Okay, we're trying to find the mass. And by the way, mass is usually in grams. Okay? So we're trying to find mass. I'm going to put grams here. Okay? Next, for the conversion factor, this is where the triangle will be a lifesaver. Look at the relationship. We're looking at the relationship between liters and grams. And remember, they're all equal to each other. Now, do you guys remember molar mass? That's where you add up all of the different atoms based on how many you have. In this case, we have carbon dioxide, okay? Meaning carbon is 12 and oxygen, there's 2 of them, but they weigh 16 each. So you add it up, and when you do, it ends up to be, what is it? Anyone have it?
44.
Actually, I have it. Okay. It is 44. Okay, so this is your conversion factor. For every 22.4 liters, yes, thank you. Okay, 22.4 liters of carbon dioxide is equal to 44 grams of carbon dioxide. That's the conversion factor. Now we set it up. The first step is to write what was given. We have, for the solution, 7.98 liters, and you guys prefer it as a fraction. We set up the conversion factor. What goes on the bottom from the conversion factor that we have here? Is it 22.4 liters or 44 grams?
22.4.
Yes, we want to cancel out the liters. They will divide with each other. Divided by, and then on top would be the grams, 44 grams of CO2. The liters cancel out. And I need you to punch it into the calculator and make sure that you know how to do this. You will punch in 7.98 times 44, divide it by 22.4, and make sure you get the same answer I have, which is 15.68 grams of carbon dioxide. Okay, so that is the first one. But honestly, what you're going to discover is they're all done exactly the same way. The only one that you have to probably do a little work for would be the molar mass, where you have to calculate the number of atoms and add them all up together from the periodic table. Okay? So, did we get that answer? And if not, I can help you. Yes? You multiply the top numbers. So even if it was a whole row of numbers, you'd multiply everything on top. Then I would just push enter and divide anything that's on the bottom, and you should have 15.68. Okay, I would like to try the next one. Now, by the way, the homework for tonight, you get every one of these different variations. They'll give you one of the four and ask you to find another. Yes?
Wait, shouldn't you divide the 44 by the 22.4 then?
You want to cancel out the liters.
Well, I mean, I understood that, but the way you...
Anything in the numerator is multiplied together. Anything in the denominator is divided.
I got a different number when I multiplied together.
This goes back to the beginning of the year. Okay, let's try another one. Yes?
Why do you use the 20%?
Well, that is the relationship between liters and molar mass. They're all equal to each other. Okay, so you just have to memorize the triangle for the test. Okay, so number 2, what's the given? 62.5 of NH3. We're trying to find molecules. The conversion factor. Okay, so now we look at the relationship between grams and molecules. As you can see, the molar mass, which we will have to calculate, it will be 1 nitrogen and 3 hydrogens. If you look them up on the periodic table, together the 14 and then the 3 hydrogens will equal about 17. Okay, and they will be equal to 6.02 times 10 to the 23rd molecules. Whether you call them molecules, atoms, or particles, they're still super tiny, microscopic, and it is very hard to weigh something so small. Okay, so let's write down the conversion factor. For every 6.02 times 10 to the 23rd, in this case, it's molecules, it will be equal to what? 17 grams of NH3. It's just the molar mass, okay? Then you will start the problem with what was given. This is the solution, 62.5 grams of NH3. We'll make that a fraction. Okay, what goes on the bottom that we're trying to cancel out? It's the 17 grams of ammonia. And the top part of the conversion factor will be the 6.02 times 10 to the 23rd molecules. The grams divided by grams cancel out in your answer when you do the math. And this is the part that gets tricky because some of you might have forgotten how to punch in scientific notation. But when you do this, your answer should be okay, guys, remember how to punch this in. You would do 62.5 times 6.02 second function, the two capital E's, remember that? And then 23. You'd push enter and then you divide it by 17. You might want to make sure that you do know how to punch it into the calculator. But again, you multiply anything in the numerator and divide anything that's in the denominator. If you guys want to try it, go ahead. But I'm going to go ahead and start setting up the next problem. See if you get this answer. Yes?
So after the answer, it's just molecules, right?
Yes, because they're still there.
Okay.
Yes? It's just the molar mass. Look up here. Look up here a minute. Molar mass, which is the adding of all of the atoms like we did homework yesterday, is equal to the number of particles. So they're all equal to each other. Whatever it weighs, whether it's the molar mass of carbon dioxide, that is going to be equal to 6.02 times 10 to the 23rd. If it's the molar mass of, I don't know, potassium chloride, whatever it is, I know this is hard to wrap your brain around. Whatever the molar mass of any given compound, it will always be equal to 1 mole, and it's also equal to 6.02 times 10 to the 23rd atoms, molecules, or particles. It's just a new topic for you, so it might be hard to, grasp it in the beginning. But honestly, what I can say is if you memorize the triangle, you'll be in good shape. You just have to know to use the triangle every time. And by the way, on the board, I did write for the molar mass. It's where you add up the masses. Hopefully that will help remind you that that's where you add them up. Otherwise, the other three numbers are always going to be the same when you do the conversion factor. Okay, so let's try number 3. What is the volume? Now, volume is what? Which one do you think of? What side of the triangle? Yes. Which one? Is it the... It's liters, guys. The volume is measured in liters.
So it would be the bottom.
Yes, the bottom. Okay. So let's do this. The given is 2.31 moles of ethane. We're trying to find the volume. Now, the volume really means liters in this case. That's the space that it takes up. It's the size of that box. Conversion factor. Okay. Now we're just going to look at the conversion between these two. How many moles are in any given volume at standard temperature and pressure? Well, you tell me, what's the conversion factor? Anyone? What's the relationship between moles and liters from the triangle? 22.4 liters is equal to how many moles? Just 1. And so that's what you would write for your conversion factor. That 22.4 liters. And I'm going to go ahead and keep the C2H6 in it. So you can see that regardless of what it is, they're all equal to each other. Okay, now we can do the solution. we're given the 2.31 moles of C2H6. We want to get rid of moles, and we're trying to get liters, so the 1 mole goes on the bottom. And the 22.4, these are equal to each other, goes on top. The moles cancel out. So now, mathematically, all you have to do is multiply everything in the numerator, since it will be divided by 1. Now, this is simple math. Okay, that was not too bad. We're going to do one more. And really, that's what the homework is like. You do many variations of going from one to the other, and you always use the triangle. Yes?
We just rounded to 51.8.
Well, 0.7? Is that what you mean?
No, yeah, 0.7.
Yes, you could. Okay, yes. I'm sorry? You just multiply everything in the numerator. Okay, let's try the last one. I'm so proud of you guys.
Not that on the recording.
I don't care. See, it's not a bad thing. Okay, we are given, yes, yes. Okay, I'm going to show only the bottom. Let's do this. Okay, the given, they tell us we have 5.30 times 10 to the 28 particles of sodium chloride. Okay, what are they asking us to find, people? Mass, which is in grams. Okay. We have the conversion factor. Now look at the triangle. What is the relationship between mass and particles? Well, you have sodium chloride, so you'd have to add up sodium and chlorine. There's one of each to find the molar mass, and it will be equal to 6.02 times 10 to the 23rd. In this case, particles. Okay? So, what is the mass of sodium chloride? Let's see. Sodium is close to 23. I'm just going to round it off. And then chlorine is 35.45. So when you add them up, you could just as easily say that you have 6.02 times 10 to the 23rd particles. Okay, and then we have the molar mass of sodium chloride. Let's do the solution. You start with what was given. What goes on the bottom from our conversion factor? Yes, thank you. For every 58.48 grams of sodium chloride, okay, the particles will cancel when divided. So now, these are the ones that are harder to punch into the calculator, and I'm going to come around and make sure you know how to do them. But you will multiply anything in the numerator, divide by anything in the denominator, and when you do, your answer will be, now, my calculator spit it out as a whole number, or you could have it in scientific notation.
Can you zoom out the thing so you can see the whole problem?
Okay, hold on one second. I'm going to see ya.